Hello everyone. In this video we'll be taking a look at the unexploitable shoving feature, which can be activated with this icon in the toolbar. In the first half of this video I'll demonstrate the feature. In the second part I'll go over the algorithm behind it. So let's have a look at the feature in action. For that I have prepared the example that is on the screen right now. Small blind raises to 3 blinds and big blind 3-bets to 9 blinds with his 40 blind stack. Small blind now decides that he either wants to shove all in or fold, and he wonders what the optimal range for this would be if big blind knew his shoving range and reacted perfectly. In order to solve this, you could of course try a large number of ranges by hand and see which performs best. Let's try one example right now. Small blind could for instance try shoving all in with pockets and ace king, and fold all other hands. Now if you were to do this, let's see how big blind's hands would perform against that range. Let's make him call all hands and let's compute. So let's mouse over the call. The green hands are the ones that are plus EV and the red ones are minus EV. Let's remove the minus EV hands from the range by pressing Alt plus D, which is one of the available toggles that are listed at the bottom of the pop-up. So now let's add a fold all hands at the bottom and recompute. So it appears that this shoving range would make $1.62 every time small blind would get into this spot. Now of course trying many different ranges by hand to find the optimal range would take ages. Luckily the software offers the unexploitable shoving tool that will automate this entire process for you. All you need to do is set a checkpoint at the decision where you want to shove or fold. To do that, press the checkpoint symbol in the toolbar, and now click on the decision where you want to shove or fold, and now press the all-in button. And that's it. The program has just tried shoving every conceivable range from the top 100% down to the top 0%, and this is the best range that it found. It is a near optimal shoving range for this spot if we assume that we're playing against an opponent that reacts perfectly to our shove. Apparently the range with the best performance that was found is the top 37% of hands, and Hero will make $2.03 every time he gets into this spot. And that's basically as easy as it is to acquire a near optimal shoving range. Just set a checkpoint and press the all-in button. Now, I have used the term near optimal a couple of times to describe the range the software arrives at, and I would like to elaborate on this a bit more. Near optimal means that the answer the software arrives at is extremely close to the mathematically correct result, but it's not the optimal result. It's just very close to it. What the software shows you is the best range it came across when trying ranges from the top 100% down to the top 0% at intervals of one combo. Now, logically, if you're using steps as small as one combo, you would assume that this process would lead you to the absolute correct answer. To see where the problem is, let's have a look at the algorithm. There's one line blurred out at the moment, I'll get into that later. So let's have a look. First, the program initializes the range X at 100%, and then it shoves this top X%. After that, it determines which hands are plus EV for villain to call with, and then it recomputes to find the EV for shoving the top X% versus a perfect villain. And here, now that the EV for the top X% has been determined, one combo is removed from X. And as long as X is still greater than 0, the program goes back to line 2 and repeats the entire process. Finally, after all values for X have been tried, the range with the best performance will be loaded to the screen. Now, the reason that it's very difficult to find the absolute optimal answer is in line 2 here. We're shoving the top X%, but it's not clear which hands are within the top X%. After all, you need to define a hand ranking that determines which hands make the cut and which don't. To solve this, line 6 has been added. After determining the EV of the shoving situation, the software will now determine how all combos rank against villain's calling range, and it's that ranking that will be used for the next iteration. As a result, it can happen that at the point where the best performing range is found, a slightly different order for the starting hands would have performed a tiny bit better. Now, from a practical point of view, this might matter a bit. The solution that the algorithm finds is as close to the true solution as it needs to be. However, a solution that's about 1% better is not completely unthinkable. Okay, that wraps it up for the demonstration of the unexploitable shoving tool itself. In the next video, we'll take a closer look at what a true mathematical solution would look like. We'll also see in the next video where, and let me just mouse over the shoving range here, these -EV hands are coming from. Every once in a while, when you let the software figure out an unexploitable shoving range, the solution will contain a -EV hand. We'll see that these -EV hands disappear when you start shoving them only a percentage of the time. In the final equilibrium, both hero and villain will have one combo that is exactly 0. Anyhow, thanks for watching. If you have comments or questions, please post them in the 2+2 forums, which are linked to in the description of this video.